Sheet 4, Problem 4.12. Determine the true size of the angle formed by the planes ABC and BCD. Keep your drawing sheet, your set squares and a protractor beside you, because we are going to draw this together, line by line. First, set the sheet up. Draw the XY line across the middle. Everything above XY is the front view, everything below it is the top view. Now put in 4 thin vertical projectors. Start at the left with the one for D, 28 mm to the right gives you C, 10 more gives B, and 15 more gives A. Those 4 verticals carry both views, so every point stays lined up. Now the front view, above XY, measure the height straight up from the XY line. D' is 56. C' is 46, and A' is also 46, so A' C' comes out horizontal. B' is only 12, low down near XY join A', B', C' for the first plane, and B', C', D' for the second. Then the top view, below XY. These distances are measured downwards from XY, and each one tells you how far the point lies in front of the vertical plane. A is 40, B is 10, C is 50, D is 25. Join the same 2 triangles. That is figure P4.12 complete, and everything from here on is your own construction. Now look at what you have drawn. The 2 planes share the edge BC, think of them as the 2 covers of a book, hinged along BC. The angle we want is the angle you would open that book to. You cannot measure it in either given view, and here is the reason. In the front view both planes still look like areas, triangles. In the top view, the same. An angle between 2 planes can only be measured when both planes have shrunk to straight lines. So our whole job is to find the one view in which that happens. The rule from the sheet tells us exactly where to look. 2 intersecting planes both appear as edge views in the one view where their line of intersection appears as a point. So if we can get BC down to a single point, both triangles must flatten into lines, and the angle between those lines is the true angle. BC is an oblique line, it is not true length in the front view or the top view, so we cannot look down it in one jump. It takes 2 auxiliary views. The first one gives us BC in true length. The second, taken looking along that true length, closes it to a point. Step 1. Take your set square, line it up with B', C', and slide it across to the left until you are about 20 mm clear of the front view. Draw a thin line there, exactly parallel to B', C', and letter it F'1. That is the fold between the front view and your first auxiliary view. Parallel is the whole point, a line comes out true length in any view taken parallel to it. Step 2. From A', B', C' and D', draw projectors at right angles to F'1, running away from the front view. Set your square against the F1 line and all 4 come out in one sweep. Keep them light, they are construction lines. Step 3. And this is the step that decides whether your drawing is right. Every distance in a new view is copied from the view you skipped over. We came from the front view, so we skipped the top view, which means we measure how far each point lies below XY. A is 40. B is 10. C is 50. D is 25. Take each of those 4 measurements with your divider, and step it off along that point's own projector, starting from the F1 line and going outwards. Mark the ends A1, B1, C1, and D1. Step 4. Join A1, B1, C1, and B1, C1, D1, the same 2 triangles, seen from a new direction. Now check yourself before you go any further, measure B1, C1. It should read 53.4 mm. That is BC in true length. If you are out by more than half a millimeter, one of your transfers is wrong, fix it now, because everything after this depends on it. Step 5. Set your square perpendicular to B1 C1 this time, and about 15 mm clear of the first auxiliary view, draw a second fold line. Letter it 1/2. Think about what this does. A view taken square to a fold line perpendicular to BC is a view looking straight down the length of BC. Look down a pencil end on and you see a dot. That is what is about to happen to BC. Step 6. Projectors again, this time perpendicular to 1/2, which is the same as saying parallel to B1C1. And the distances? Same rule as before, go back to the view you skipped over. This time that is the front view, and you measure each point perpendicular from the F1 line. A prime is 68. D prime is 20. And now look carefully at B prime and C prime, both of them are 44. They are equal, and they had to be equal, because we drew F1 parallel to B prime C prime in the first place. That equality is your guarantee that BC is going to close to a single point. Step off those 4 distances from the 1/2 line. B2 comes out 44 along its projector, and C2 comes out 44 along its projector, and because the two projectors are the same projector, the 2 points land exactly on top of one another. BC is now a point view. Ring it, and letter it B2, C2. Step 8. Mark it 2 and D2 as well, and join each of them back to B2. Notice that you only get 2 straight lines, there are no triangles left. B2A2 is the whole of plane ABC, seen edge on. B2D2 is the whole of plane BCD, seen edge on. Exactly what the rule promised. Step 9, the last one. Put the center of your protractor on B2, line the base up with B2A2, and read off to B2D2. 125.8 degrees. And this reading is the true size, not an apparent one, because you are now looking exactly along the hinge line BC. 125.8 degrees. Write that under your figure, and leave every construction line on the sheet. In descriptive geometry, the construction is part of the answer. One last thing, so you can trust the drawing. Forget the projections for a moment and treat the 4 points as coordinates in space. Take the parts of BA and BD that are square to BC, and find the angle between them. It comes out 125.79 degrees. The drawing and the arithmetic agree, which is exactly what a correct construction should do. So, the recipe, and it never changes. Find the line the two planes share. One auxiliary view parallel to it gives you its true length. A second auxiliary view perpendicular to that true length turns it into a point. Both planes fall to edge views, and you simply measure between them. And remember the one rule that ties it all together: the distances for a new view always come from the view you skipped over. Try it now on Problem 4.13.